Yeah, comes on everyone. Let's start off. The last thing, this is the thing which we are doing. J is equal to sigma E. Let's start off with a question. Hmm. Let's get them. Hmm. So in a wire of cross section, free electrons travel with V. Current is I. There was a current another of the radius of same metal when the drift velocity is 2V. So basically, I is equal to NEAB. So I is proportional to the radius, so pi r square into V. So you're saying radius becomes half and the speed becomes double, so it becomes half. Easy, straightforward question. Second one, resistivity of a semiconductor decreases increase in temperature. This thing we wrote, true. In a conducting solid, the rate of collision between temperature, that is also true. Yeah, both are true. That's not the explanation. What is the explanation for it? Explanation is the number of free electrons will become more, isn't it? In a semiconductor, when you heat, more electrons are released from the atoms, so the number of free electrons will increase, so conductivity increases. The reason is different. Whereas in a conductor, you already have a lot of free electrons, but the collisions will increase. What about C? So both are true, but it's not the correct explanation. So try. I'll give you a minute. C is a good one. An insulating pipe of cross-section area A contains an electrolyte which has two types of ions. Charge is minus 2e, the potential difference applied between them. So minus E is going with V and 2e is going with V by 4. Now understand the flow of positive charge is the current. If the flow of negative charge is opposite to the current. So I1 will be NEA V, I2 will be N2EA V by 4. So the total current will add up. Because when you take a solution, electrons and positive charges will go in the opposite directions. Flow of positive charge is the current direction. Flow of negative charge is opposite to current. That means currents both will add up. Be careful with that. That is a mistake people generally do. They subtract it. Clear? Easy one, but be careful. Hmm. Get these two. A wire uniform cross-section shown in the figure. A steady current flows through this thing. The drift velocity is I is equal to NEAV. Remember, current is constant. This thing is like equation of continuity. We get AV is constant. So more area, less velocity. So VP must be greater than VQ. E is a good one. Hmm. Look at this thing. A metallic conductor of irregular cross-section is there. Constant potential difference is applied. Fair enough. Now you need to understand current will remain same. It doesn't matter how thick it is or thin it is, the current will remain same because it's the same amount of charge that is flowing. So A is right. P equals the simple reason, same charge flows per second. Current is simply charge flowing per second. I don't care about the area. The electric field intensity at P is less than at Q. We know current density J is equal to sigma E. And we know J is nothing but current by area. So we can clearly see E is proportional to 1 by area. So both the things current is same. So whoever has more area will have less electric field. So P is also right. The rate of heat generated per unit time at Q is greater than this thing. Now this I still didn't do, but heat per second is nothing but power, which is I square R. Current is same. R is nothing but rho L by area, meaning if you take for a small length. So this is proportional to 1 by A. So the thinner cross section will have more resistance for the same given length. Getting it? So it will produce more heat. So QC is also right. And this is one of the reason actually. What happens, when the wire becomes thin, at that spot you produce more heat, so it gets heated up more, so it melts more. Eventually it becomes more thin and it finally breaks. So it becomes a cycle. The thing gets kills itself. Next thing, number of electrons crossing per unit area. Now, when you say per unit area, current is same of cross section at P and less than Q. So indirectly it's asking you J only. So this is also right. All are right.
Sir, I have a doubt in B.
What is your doubt?
We wrote E is proportional to 1 by A.
I by
But
A.
sigma will also change, no? So sigma will also change, no?
Okay. How will sigma change?
There was some formula of rho. I forgot that actually. But it was
Okay.
dependent on the conditions. Can you show the formula?
Mm.
I don't know, it wasn't dependent. Okay, never mind.
Meaning if I take 10 grams of, gold, and if I take 20 kgs of gold, both ka densities will change because we are taking 20 kgs.
No, sir, they won't.
Resistivity and conductivity are property materials, God. Why will they depend on area?
Sorry, sir.
नहीं सॉरी नहीं बस बोल रहा हूँ कुछ नहीं हो गया भाई टू बी सॉरी एग्जाम में 4 मार्क जाएगा बॉम्बे के जगह गुवाहाटी जाएंगे प्लेन टिकट ज्यादा लगेगा बस मस्किटोस भी ज्यादा रहेगा यू हैव टू बाय अ मस्किटो बैट नेक्स्ट थिंग if you don't like Guwahati, you can go to Gandhinagar. That is only 10 hours by road. Next thing. So getting it, so these are some questions, not tough, but these are good theoretical questions based on, whatever things we read. So we have a solid cylinder. The current density J is J naught into 1 minus small r by capital R. It's an easy one, where r varies between capital R to 0. R is the distance from the axis. Find the current in the cylinder. J is the current density. Meaning if you look at this function, when you put smaller is equal to 0, I get maximum. Meaning at the center you have a maximum current flowing. Then as you go outside, current decreases, and becomes 0. So this is how the current is flowing inside this thing. So the current is maximum at the center of the cylinder and it decreases as you come outside to the circumference. Whereas in reality, it is actually reverse. More current flows on the surface and less current flows inside. At least AC current. That is a thing called the skin effect in AC. We don't have it, but yeah, just an idea. Find the current in the conductor. Remember, J is nothing but current per unit area. Let's get this. Any answers? Pi j r square by 3. Okay. Hmm. Yeah. Right, Ishan. Yeah, most of you got it. Easy one. So what we do at a distance x from center, take a thin strip because j is changing. You can't do directly j into area. So take a radius r and a small dr. So the current I would be integral j dA. This is j naught 1 minus small r by capital R into that area of that ring is 2 pi r dr. And this goes from 0 to r. This thing turns out to be j naught pi r square by 3. I'm just writing the answer. You can simplify it. Easy, that's it. कुछ नहीं था इसमें. Like I said, on J, right, we'll play mostly in magnetism. There I'll ask you find the magnetic field inside the cylinder, outside the cylinder. There it becomes more useful. Right now, not much. Clear? Next one. So we have a composite wire. This is row 2. This is row 1. This is the interface. Meaning, let's say you take a copper wire and a steel wire and you connected them. Row 1, row 2 are resistivities. Find the charge on the interface. Something happens and charge starts accumulating at the interface. So how much charge accumulates at the interface in steady state? Basically, when I say current I is flowing, it's a steady state only. Think about it. This is a question where it is, difficult to figure out but easy to solve. Try, take a minute out. First of all, you need to understand why there is a charge. It's a neutral conductor. And how do you find that? Did you guys figure out why there should be a charge? Think of like this. I'll give you an example. See, imagine you're going on a 4-lane highway and suddenly the road converges to 2-lane. What will happen? What will happen at that intersection when that happens? You'll get a traffic jam. So when you say composite wire, you're taking two wires of different, charge carriers or, different resistivity. So all these electrons which are flowing will suddenly encounter a kind of obstruction. So electrons will start piling up. Now electrons pile up, what will happen? These electrons will start repelling the electrons which are coming this way. Now see, the way electrons flow is actually due to Meaning you can say like this, electrons talk to each other through repulsion. So the electrons which are coming here, they get repelled. So these electrons on the backside will slow down, whereas electrons in the front get repelled in the front direction. These things start going faster. So this charge in the middle, right, will act like a kind of a catalyst, you can barrier or something, which is actually making sure people who are coming slower and people who are going faster. So that way it will try to reach a steady state, but this charge will accumulate. Meaning imagine if 100 cars are coming here and 50 cars are going here, the charge will start accumulating, isn't it? The charges will become so much. This will become 90, this will become 60, this will become 70, this will reach 70, and finally reach a steady state. Incoming is equal to outgoing, the charge got accumulated there. Clear? This is generally what happens, when you build highways and all, people don't think properly, especially in Mumbai. If you think about this thing, right? Whoa, what is that thing? That bridge is there, right, across that sea link. Right?
Andhra World.
नहीं वो है ना, वो Bandra में that only, that sea link only ना. So if you see that road, right, when these people built, their intention was to reduce the traffic. So if you look at the Mumbai ka map, right, it's something like this. So they built the bridge something like this. They wanted to reduce the traffic. These very intelligent people, what they did, they built a super 4 or 5 lane here. You can see it's pretty smooth. Once you get onto that, you will just rush. But the problem is these things at end of the day, when they come and finally end, they end at 2 lane roads. Because you have to develop this infrastructure also. So what they simply did was they took all the traffic from here and they shifted the traffic here. So in civil engineering, you learn this thing. So this is what you do. When you're building something, you're just pushing the traffic further north. Now they'll build something here called, whatever is that, the Bandra Sea Road or something, a coastal road and everything, and the traffic will shift it even more up. You'll just keep pushing the traffic. Traffic will still be there. So something like that. Someone was, Anusha was asking, what if the other side is less and this side is more? Think of like this, right? Suddenly, like you get a more this thing to flow. So these things were coming little restricted, right? So once you reach here, they'll go much faster here. You start getting holes here. Right, Anusha? So it's not only electrons, right? If electrons go too fast, what will happen? Suddenly you're leaving holes there. There's too much vacancy that you're creating a gap. So even though I said like a traffic now, you need to understand one thing. How do electrons actually move? The whole thing is neutral. This electron is jumping here, this electron is jumping here, this electron is jumping here. Are you getting it? These are how electrons are jumping from one atom to another atom. So once you come to this kind of a place here, what will happen? The electrons can go much faster. So by the time this electron comes here, these things have already jumped ahead. You started getting holes. Making sense? So anyway, it is easy to understand if you think like electrons are just moving, but in reality, electrons are jumping from one atom to another atom. They're just going around. So you start getting holes. Either way, the charge will accumulate, whether no matter what is there. So one thing is clear, charge will accumulate. No, that totally depends on rho 1 and rho 2. So let's see how to calculate that. So we will assume this some charge is there here. How do we get this thing? So we consider a Gaussian surface. Because think about it. Till now, we didn't have anything else but Gaussian surface to give this thing. So on the right hand side, let the field be E2. On the left hand side, let the field be E1. Now the flux through this Gaussian surface will be E2 into area minus E1 into area is equal to Q by epsilon. That's the charge enclosed. But what is E2? We know J is equal to sigma into E. I can write this thing as 1 by rho, that is resistivity into E. So field will be rho into J. So this guy would be rho 2 into current density J into area minus rho 1 J into area is equal to Q by epsilon. J into area is nothing but current. It's the same area of cross section. So this guy becomes rho 2 minus rho 1 J into A is I, epsilon is equal to Q. So if rho 2 is greater than rho 1, you get a positive charge. If rho 2 is less than rho 1, you get a negative charge. The science will take care of it. How much charge will accumulate will depend on the current flow and the difference in resistivity. If rho 2 is equal to rho 1, means it's the same material, you'll have zero charge distribution. Clear with this? Like I said, it is easy to solve, but you need to figure out what the hell is happening in the first place. So it need not be positive charge. It can be positive or negative depending on the values. Clear? I hope the idea was clear. Why charges accumulate when you put composite wires? So generally, when people think you're just putting a flyover or something like that, what can you imply from row 2 being more than row 1? Yeah. Isn't that what we discussed till now? Push, push. All that story I told you is that only. Positive charges and all. Kya tha wo, electrons jumping. What are you doing? You're listening the story for something else.
No सर लाइक मतलब लाइक अपने दो केस डिस्कस किए थे ना इसमें लाइक हम मोर से लेस में जा रहे थे लेस से मोर वाला केस था सो लाइक
Less से more से क्या होगा? That's what I'm saying. Electrons will go away so fast. There'll be holes there.
ओके तो एंड इफ रो 1 वाज ग्रेटर देन रो 2 तो फिर इट वाज मोर से लेस
Yeah.
ओके
Meaning, it is like you're going from 2 lane to 4 lane. More resistivity to less resistivity. Clear? Next thing. Combination of resistors. So first thing is series. Again, this is the same story as this thing, but here we say this is the same current and same branch. You can replace this with one resistor, R1, R2. So R equivalent is R1 plus R2. They have same current. So V1 by V2 will be R1 by R2. So the voltage will divide in the ratio of resistances. Parallel, same potential difference, same nodes. So be careful again, capacitors ka it's little reversed. Current will split I1, I2. I1 by I2 will be R2 by R1. More resistance, less current will flow. This thing we already done. This is the fourth time already. if this ratio is maintained, R4, R5, and R6, then you can remove R7 and 8. Have a look at this. Not row 2 more than row 1. I think Kush, you are asking something else, I guess. I think this way, see, I'll tell you what. If you have more resistivity, means it's more difficult for them to flow, right? So you should have more velocity. I is equal to NA VD, na? Current is same. So when you say more resistivity, when you say I is equal to NA VD, na? Current is same. So more resistivity matlab socho N is less. E is same, area is same. So drift velocity has to be more to compensate for it. So higher resistivity will actually have faster electrons. Because there's more resistance in order to oppose that, you have to go faster. I think वही पूछ रहे हैं ना, तेरा plus minus का वो issue आ रहा है तुझे.
Yes, sir.
Clear with this stuff? This though you already know. This is the fourth time you're saying. First time we saw in heat transfer, then we saw in Poiseuille's equation, we saw in capacitors, now we're seeing in current. Let's see some questions. So
Sir, in
again,
which
same
equation?
thing. Which equation?
So you said something about an equation.
Which
We saw
equation?
this in-
Nothing. We saw that in the World Economical, that one.
I think
World Econ.
Poiseuille's the one which is in viscosity.
नहीं, I'm just
Poiseuille's
joking.
equation.
Poiseuille's equation रे, उसको सुना ही नहीं दिया. You guys now want to mess it up. मैं उसको तो joke कर रहा था. I was about to say world economics करके. Something like that. Clear? Let's see some questions.
Then extended Wheatstone, it's on the same branch ka ratios.
It doesn't matter, right? See, like you have this ratio and this ratio or this ratios.
Okay.
It works.
Right.
Something. You can take horizontal or vertical, it works. But remember, like I said, everything should be removed. I think in capacitors I give vertical, na? Here I just changed it a bit.
Okay.
Let's see our question. We got a cuboid. Yeah, you should see in medical students, they do more stunts actually. Like this only. I was saying a question, they're busy doing something else. And they're like, sir, what is the question? I said, find the cost of the train. Okay. They wrote that down. And they're thinking, kya hai, cost of the train kya hota hai? And they really thought that's the question for some time. Anyways, ho gaya medical, this year is the last. So there we have
won't be
6.
taking medical anymore.
No, ho gaya medical shutdown. I got bored of them actually. They come to the class only with a face like we hate physics now, teachers. Kya padhayenge usko? They're more happy if you give them 10 formulas. They don't full-set explanation. Kuch nahi hai, they don't want to think. But they'll score 120s and 130s out of 180, but they need to score pretty high. Abhi dekh raha na, people are scoring like what full aa raha hai. 720 out of 720. I tell them that only. Learn how to bubble properly. Next year, NEET bubbling ke liye 1 mark extra milega. You'll get 720 plus. NEET में it is possible now. Anyone can score. Bloody 67 people scored full marks. What kind of exam is this? There was, just imagine, the girl student who got 711 out of 720, her rank was 360 something. And she's crying because she's not getting a medical seat in the college she wanted. The problem wahi hai na. Now see, if you and I start getting the same score, you know how they will decide the rank? Marks all equal tha. That is all same. Then they have to go for other things. I mean, eventually there's a criteria also. Whoever applies the application ka number first, uska better rank aayega. Right? Now, if I and Utsa wrote the exam, because I'm older, I'll get a better rank. Because Utsa is younger, so she can wait. By chance, our age is also same. Then they'll see the application ka number. Who applied first, they'll get a better rank. And if you start giving ranks based on the application number and age and everything, yeah. Chalo. Now we have a cuboid here, ABC. So 6 faces are there. Find the ratio of resistance. Across R12, R34, R56. 1 and 2 left and right, 3 and 4 is up and down, 5 and 6 is front and back. So if you keep the battery between these faces, what is the resistance? Let's get this. Easy one, mostly a bits level question. This is. Remember when I say rho L by A, what is L? L is the length along the current flow. What is A? Area perpendicular to the current flow. So be careful. Meaning people say rho L by A, but they don't know what is L and A. They think length and area. What length and what area? It depends. So if you look at R12, so you're going from 1 to 2. So rho length will be A and the area will be BC. When you go from 3 to B, this will be C and the area will be AB. And this will be rho B by AC. Multiply and divide by A. So this is A square is to C square is to B square. But there's a much faster way. Resistance is rho L by area, multiply length and multiply length divided by length. So this will become rho L square by volume. Since the volume is constant, so you can simply say R is proportional to L square. That will be much faster. A square, C square, B square. Right? How are you getting ABC? Be careful. A square, C square, B square.
हाँ, वो कंप्यूटर बोल दिया ACB only.
Clear with this thing? This is a faster way. You just multiply and divide by length and you will get this thing. 3, 4 ka, yeah, 3, 4 is rho C by AB, right? So clear? Let's see one more. So we have a cylindrical resistor. This is a resistances R. So someone took this. This is melted and recast. When they change the shape, it became like this. They made a rod of square cross section, like a Kit Kat. Turn the page here. None. So they made this thing, square cross section, side A. Find the resistance. And someone made this into a triangular cross section, Toblerone. Right? And if I take this length to be L, let's say this length is L by 2. This is an equilateral triangular cross section. Find the resistance of both of them. Let's say this resistance is R1, this resistance is R2. Find R1, R2 in terms of R. Length of the square, length is not given. Only side is given. That equilateral triangle ka side length is given, but cross section ka side is not given. Anyway, volume is constant, तो वैसे measure कर सकते हो. Let's see. Finish off 30 seconds. Let's see. So the first thing, right, whenever you get something like this, resistance is rho L by area, multiply and divide by length. So this guy becomes rho L square by volume. So understand, whenever you melt something, volume remains constant. So you can write like this, or rho L by area, multiply and divide by area. This becomes rho volume by area square. So depending on what is given, you can use the appropriate formula. So in the first case, if you see, it's a side is given. So R1 by R, so we can use that area 1 will be A square by A1 square. So this would be pi A square ka whole square by A square ka whole square. So R1 will be pi square R. For the second one, length is given. So R2 by R would be L2 square by L square. L2 is L by 2, so that is 1 by 4. So R2 is R by 4. So there's no need to find the area, length, and everything. I don't care about the triangle shape. That is just a trap. So if you use this thing, you get the answer fast because volume is constant. It is time waste actually to find that side using volume conservation and then trying to substitute. Better get the formula mein only volume. Clear? That's an easy one. Next one. Turn the page. We have a solid sphere with a cavity. Inner radius is A. Outer radius is A. Someone connected a battery between these two terminals. This is grounded. Meaning you're making the outermost potential 0 and the inner potential is V. This thing is like the capacitor's ka last problem we did. So rho is equal to rho naught X. Rho is the resistivity. X lies between 2A to A. This would be a good advanced paragraph question, right? Find R equivalent. Find I. Find the current density as function of X. Find the electric field as function of X. Find heat produced per second per unit volume. I know I didn't teach you heat, but you know I square R, you can use that as function of X. If they'll ask you a graph, they'll say plot heat per second per unit volume as a function of X. Find the potential as function of X. And this is not the first time we did. Heat transfer did the same thing. That was even better than this. Let's get this. Outer sphere is two-way, sorry. लॉन आया क्या? Possible. Set a distance x, take a thin shell. So resistance of this thin shell is a rho dx by area. Now understand, rho L by area, what is L? L is the length along the current flow. How is the current flowing? Current is flowing radially. What is area? Area perpendicular to current flow, which is the surface area, the cross-sectional area. So this guy is rho naught x dx by 4 pi x square. So this is rho naught by 4 pi dx by x. Integrate this. So R equivalent would be rho naught by 4 pi integral dx by x from a to 2a. This would be rho naught by 4 pi ln 2. Current is easy. V by R equivalent. V by rho naught 4 pi ln 2. Current density is also easy. What is current density? Current which is constant by area 4 by x square. What is field? Field is nothing but J is equal to sigma E. So it is J by sigma or rho into J. So that would be rho naught x into, this is I by 4 pi x square. So this they can ask as an integer question, 1 by x square function. This is proportional to 1 by x. They can ask like that, it depends on x power n, what is n karke. What does it ask? Heat per second. How will we do that? And potential. Try. I'll give another 2 minutes. So once you got the current, J and E will come straight forward. So in case you're confused, I used J is equal to sigma E, and sigma is nothing but rho. So I just shifted it. Can you find the heat per second per unit volume? Meaning for that small thickness dx, how much heat is it producing per unit volume? And find the potential as function of x.
Can you show the next page?
Now look at that thing. Heat per second. We know heat per second is nothing but power. Now, like I said, this formula you learned from school, so I'll just leave it there, I square R. So now you want heat per second per volume. So this guy is I square dr. We are talking about the thin cross section. The volume is 4 pi x square dx, isn't it? So I is anyway constant, so that is fine. What is dr? Dr, so we got it from here. Dr is rho naught by 4 pi. Dx by x by 4 pi x square dx. The dx will cancel off. You end up with I square rho naught 16 pi square x cube. So this is proportional to 1 by x cube. Clear? What about the potential difference? So heat is I square R, I is constant. So main idea is that let rho change, let anything change. In all these kind of questions, right, I will remain constant.
So I send something for potential.
Dekh then, patience.
In the first part, we're kind of
Mhm.
assuming that like when the current reaches the outermost shell, there won't be any
Mhm.
resistance when it's flowing tangentially to the
Think
wire.
of like this, na? Meaning there are two conducting shells there. In the middle, you filled up the medium. Aisa socho.
Yeah, so when the current reaches the circumference, like
It's a conductor, na? So all have same potential, so it won't matter.
oh right, right.
That way. Think of like two conducting shells. Beach way it is filled with a material.
Understood.
That way. So I can write that basically. Conducting shells filled with a medium. Let's see the resistance thing. Now, when you take this thin thing, how did you get log to the base 2 ray? That is interesting. Physics में generally, right? Log 10 भी नहीं आता है. The only place I think you have seen log 10 till now is in decibels. Everywhere you'll get ln only.
Actually, I got ln a by x by ln2. I made it log 2.
Okay. Let's see. I'm not so good at maths, so this is I. So across this small thickness, right? What is the potential difference? So dV is I into dr. There's a potential difference across the thin shell. This is the potential difference across the thin shell. So dV, current is anyway constant, so I'll just keep it there. And this will be rho naught by 4 pi dx by x integral. This potential is 0, but where? Potential is 0 at 2a, and this potential is V at x. So V is equal to rho naught I by 4 pi. That would be ln x by 2a. I value you can substitute. Clear? Yeah, I think you can do something with that ln 2 and stuff, but okay. So when they ask you potential difference, this is the best way to do. Faster, you'll get this thing. And remember, this is not the first time you're doing. This is the third time. We did this in capacitors also. Same logic, if you remember. There we wrote Q is equal to dc into dV. Small capacitance into small potential difference. Heat transfer, we could do the same thing. Heat transfer, it is the dq by dt. Heat current is constant. We used to write K8 dt by dx, temperature gradient. So this is constant, and dx and integrate. This is the third time, current electricity. So these are quite important models. That's what I'm saying. When you see questions like this, right, think like that. Okay, this is here, this is here, this is here. Then you won't feel it, it is overwhelming. Arey yaar, itna kya hai different. You will realize you are playing the same thing in different chapters. Clear with this? Let's see one more.
Sir, how will it be 2A?
Okay, what it should be according to you?
A from A to X.
Why A to X? What is the potential at A?
Oh, it's V.
Yep.
I have to write minus dV.
Minus dV because it is dropping, na? Yeah, sahi bol rahe ho. He's right. Because it is decreasing. He's right. Rho naught by 4 pi ln 2a by x.
Anyway,
Hmm.
competitive because 2A is really greater than X.
हाँ but ठीक है. Potential drop, right? It is decreasing, so minus. Next one. This is a good one. Right? This is a much better one. So we have a piece like this. This is angle theta. And in the top view will look like this. It's an arc. And you're connecting the battery between these 2 points. So basically this entire thing is like a plate here. Getting it? So battery is between those two. Voltage is V. This is the top view. This length is L. This width is D. This radius is R. And you can take R is much greater than D to neglect the Ijga effects. I'll do one thing. Let's take it as A because R will be resistance also. So A will be much greater than D. You are connecting the battery between here B and the battery here between A. So find R equivalent. Find current. This is fine. Second one would be interesting. Find the drift velocity as function of x. So the electrons will also have a drift. Rho is the resistivity. Find transverse voltage. That is PC minus VD. So C and D are these. The outermost surface and the inner surface. Something happens and these things get a potential difference. let's do A and B. See, I will teach you. See, transverse voltage is a little different concept. Let's do A and B. A and B is still in our hands.
So we'll assume resistivity, right?
Rho diya na?
Ah, sorry, I didn't see that.
This is the potential difference across inner and outer arcs. Something happened because of the current flow. You'll get a potential difference across it. Negligible, but it is there. R is rho A theta D. What did you guys do exactly? Life इतना easy नहीं है record. What did you take? You took rho L by area, right? तो area तो L into D ले लिया. Perfect. Length कितना लिया? So you mean to say the length of the rod is constant everywhere? The inner surface ka length is what? A theta. Outer surface ka length is A plus D theta. What did you take as length? Even though D is small, don't neglect it. It is neglecting this for some other purpose. When I'm putting D small because we don't want the current, they just will get messed up. We don't want that. Are you getting my point? When you say rho L by area, area L into D area, great. What did you take as length as?
Yeah, I understand.
Because for this, each section, the lengths are different. This would be an advanced paragraph question. If I have to ask you this, I'll ask you find the current and I'll ask you the transverse voltage.
But then, sir, isn't A much greater than D given for that only, like so that you can take
No, it is not given that, but approximate. I'll write on that. So basically to neglect the effects of edge. They also have fringe currents basically. The currents on the edge will not flow uniformly, they start messing up. We don't want that to us. You can take Ishan, get me the final answer. Try, at least get a wrong answer, give me the answer. Are they in series? If you say they're in series, meaning you're taking elements like this, isn't it? Look at this thing, na lengths वापस different aa raha hai. You can't take them in series.
But sir, if it's d theta, then it's very small, right?
Forget about that small thing. Chalo, small nahi hai. Abhi karo. You and you're small. I was saying that small is given for a different reason. It's like saying capacitor में A epsilon by D, since the D is very small, right? Infinity ना हर बार क्यों solve करना है? Life is so easy. Capacitance कितना है? Infinity. Capacitance infinity. Done discussion. Doubt ही नहीं है. मतलब let me give you a complex circuit like this. What is the capacitance? Infinity. Solve करना ही नहीं है हमको. क्यों करना है? Because D is small ना. That D is given small for a reason. Like there is a fringe effect. We don't want to get into that. अभी उसको एडवांटेज यूज करके हर चीज के लिए स्मॉल 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 नहीं करना है. Adrit got it. Let's see. So this is what we do. At a distance x from here, take a thin strip dx. So we get a strip like this. Take a very thin strip. Because the length is changing for each strip. So this would be that area. So this area would be L into dx. And this length will be x into theta. So this strip ka resistance dr for the thin strip. The resistance length is x theta by area is L dx. And remember, all the strips are in parallel because they have same potential difference. Because even if you try to take in series again, you'll get the same problem. What the area gets messed up. What is area? Length per area is perpendicular to the current flow. Current is not perpendicular to this area. So the elements will come pretty weird. Now be careful here. This is the mistake again. So 1 by R equivalent is 1 by R1 plus 1 by R2, so on. That means for 1 by R equivalent, you should not integrate dr, you should integrate 1 by dr. Understand that integration is nothing but summation ka symbol, that is. So what we're doing is summation of 1 by drs. And this guy would be L dx by rho theta x ka integral. And x ka value will go from a to a plus d. So that would be L by rho theta ln a plus d by a. So we end up with R equivalent is rho theta by L ln a plus d by a. This is your resistance. Clear? They are in parallel. Do have a look at this. You can't take the strips here in series. Current is easy. What is current? V by R equivalent. Now find the main thing. Find the drift velocity and find the transverse voltage. Now each strip is actually different. Even though all are in parallel, their lengths are different. So drift velocity won't be same. Drift velocity will get affected. Meaning just think of a traffic, right? If all the cars go with the same speed, because the outermost car has to travel more distance, won't it take more time to reach? That means you should travel faster if you want to reach at the same time. So in each section, right, electrons are traveling with different speeds.
N is not given.
N, le lena N.
Okay.
Meaning they'll ask you V drift is proportional to 1 by x power some constant. So find that, something like that. Assume N le lena. N has to be given technically. Parallel के लिए voltage across that current should be same, right? Transverse में there is a different thing. But you'll reach a steady state, right? So initial charges will accumulate actually. There will be a charge distribution in that direction. See this thing. So I take this thin cross section here. Now, when we say I is equal to NEAV drift, this I is the current in the thin strip. I don't want the total current. So current in that thin strip is potential difference by resistance across the thin strip. That will be NE. Area would be this guy, this TX, and this is length L. L into dx into V drift. What is dr? Dr is this guy, rho x theta by L dx. So L dx got cancelled. So we get V drift is equal to the voltage by N E rho theta into x. It's inversely proportional to 1 by x, kind of expected. The farther you go, the lesser the speed. 1 by x, no? Now what is the catch? Why are you getting this transverse voltage? This is what is happening. Listen carefully. Now when the electrons start going with some velocity, this I can teach you this as a concept and a problem. This is what is happening. When the electrons are going with velocity, so at a distance x, let's take an electron going like this. So this electron will experience a centrifugal force, which is mvd square by x. It's very small, like, transfer voltage is almost negligible, but it exists. This is a centrifugal force on the electron because it has velocity. This is because of your V drift. Now, what will happen because of this? The charges will start getting induced. Means the outermost surface will start becoming negative charge. And the inside will become positive charge. And on this electron, now we will have two forces. One is your centrifugal force, which is mv square by mv drift square by x. And this would be your electric field E into E. This E is your induced electric field. So due to centrifugal force, electrons accumulate on the outer surface. Inducing charges. So these induced charges create an electric field which will oppose the centrifugal force. And then think about it, more and more electrons keep piling up. At one point, there will be so many electrons piled up, they will repel any electron that will try to come. So you reach a steady state there. So that's the reason you won't have current in the transverse direction eventually. These induced charges create a field and balance the centrifugal force in steady state. So E into E would be mv. I'll just write it as vx square or vd square only by x. V drift is how much? V drift is again V is again proportional to 1 by x. So that would be proportional to, so I will just write, Vd is proportional to 1 by x. So this is proportional to 1 by x cube. You can find the constant. So you will get some constant, some z by x cube types. So this would be a radial electric field. Z, you can calculate, Z is some constant. So once you have the field, and remember there are two types of field here. One is your E radial. The another field E is this guy J by sigma. That is a tangential field that will produce the potential difference across the thing. You want transverse voltage. That J by sigma will create the battery ka voltage. We know the formula minus integral E dot dr. That would be the constant Z by dx by x cube. This again limits will go from a to a plus t. You can see it is proportional to 1 by x square. So you can integrate this, you will end up with z by x square a plus t by a. I will leave it to you. But you got the steps. Again, have a look at this thing. This is the main story there. This is negligible, quite small. Because what is this m here? Mass of an electron. How much is that? 10 power minus 31. That kills out everything. It's a negligible, but it does exist. Clear with this thing? Because they are going in a circle instead of a straight line, you start getting a centrifugal force, and the centrifugal force drags the electrons to the outer edge, thereby inducing charges, and these charges create a field which to stop the centrifugal force. And when you have a field, you have a potential difference. Any doubts on this? So once you got the field, it is done. Clear, everyone? Take a break. Come back with 7-1. Previous page here. They are in parallel. Why do they have to reach at? No, they won't reach at the same time. Dekho na, speeds are different. They won't reach at the same time. So I was saying, if they have to reach at the same time, the speed should have been different. That's it. So यहाँ पे speeds be different. Actually, the outermost one is actually going slower also. So the outer one, the distance is also more, speed is also slow. So it'll actually take much more time.
Sir,
Aditya.
sir, I have a doubt in the seventh question.
Seventh question. क्या था?
सर इसका आपने फ्लक्स में E2m minus E1a क्यों दिया?
Because for a closed surface, we take the outward surfaces as positive area.
Oh, right.
That's the sign convention, no?
Can
Clear,
I
na?
show the last page? That integral, please.
Chalo, come back in 10 minutes. Camps on everyone. Let's start off. Find the distance between A and B. Each segment is R. Symmetries. Series parallel which will be exactly the same thing. Try. You got 2 minutes. It's easy, only calculations are a little messed up. Let's see. Let's see. Yeah, Anusha, I think you got it right. 22/35. Yeah, that is right. So we can clearly see here, this is a bisector symmetry. That means any node in the middle that can be opened up. This guy becomes like this. These two will get joined up, these will get joined up, and this will get joined up. And you can fold it also if you want. Now, if you can clearly see here, this whole section here, that is R and R, 2R is R, and this becomes R by 2. And this whole triangle here is 2r and r, 2r by 3. 2r by 3. So if I just redraw this circuit again, this is how it would look. This is 2r by 3, r by 2, 2r by 3. This is r, this is r, 2r by 3, r by 2, and 2r by 3. There, everything is in series parallel. You can solve this. I remember the answer 22r by 35. And I think some people did get this. Do check it out. Once you remove that, it simply becomes series parallel. Clear? You want, you can fold it also, but really don't make much of a difference. Let's see one more. Find RAD, find RBC. If the battery is between A and D, these 2 points here. If the battery is between these 2 points here. 2 different questions, RAD and RBC. RAD is 1. Yeah, RAD is 1. So I will do for A and D. You can see line is passing through the terminals. So axial symmetry. Meaning left and right will have same potentials. Therefore, B and C have same potential. Basically, you can fold it. E and F have same potential. Then your circuit will become like this. You can remove this guy in the middle. This can be removed. Because the potential is same, you can remove them. So resistor EF and BC can be removed. Because the potential is same. Then so you're done, right? This, all three are in series, and parallel. Aa jayega directly. So calculate this thing. RAD is 1 ohm, it seems. You can verify your answer. These three are in series, and this and the center one, all three are in parallel. Try for BC. Here, what a minute. Any doubts on this, please ask. Like this is what I taught you in capacitor, series parallel. That's what I said. The techniques will remain same. Only series parallel that formulas are different. Try BC. BC. So people are saying 7/12. Yeah, that looks right, I guess. Let's see. I don't remember the answer for this. But yeah, 3 people got 7/12. Maybe right. Now this is an axial symmetry.
Bisector
So,
symmetry.
sorry, bisector symmetry. Both the points are on either side. So that means all points on this will have same potential. So A and D have same potential. So you can remove that AD resistor in the middle. So this guy is 1. I think then it becomes easy to solve. Yeah, then it is done. These two are in series, parallel, series, series. The whole thing is in parallel. How much are you guys getting? 7/12, it seems. You can verify. Looks right though. You can see that just removing that one resistor will make the whole circuit into series parallel. Do have a look at this. Ask me if you're still confused. All clear with this? The circuits will be exactly same. The 4 techniques: series parallel, Wheatstone, nodal analysis, and symmetries. That infinite symmetries, that square grid, hexagonal, honeycomb, infinite grid, literally everything will be same. Let's go ahead with Kirchhoff's junction law. Now, again, the idea is the same thing. So Kirchhoff's junction law, what it states, the net current entering a node is 0. Again, the technique will look exactly similar, only the formula will be a little different. So if you have a resistor, you have a resistor R1, R2, R3. If this is V1, this is X, this is V2, and this is V3. I'll assume current is entering the node. You can take away also. Remember, current always goes from higher to lower potential. The I1 plus I2 plus I3 is 0. So now remember, what is current? Potential difference by resistance. So V1 minus X by R1. If you remember in capacitors, it is Q is equal to CV. So C into potential difference. I2 will be V2 minus X by R2 plus V3 minus X by R3. So the technique is the same. Assume a 0 potential, find the potentials, name the potentials, and finish it off. Let me show an example how it works. Remember this, there we wrote Q1, Q2, Q3 is 0. Here we wrote I1, I2, I3 is 0. There Q is CV, here I is V by R. So that's the difference. Let's see a question. That's what I'm saying. Don't think you're doing two different chapters. As long as you can compare the techniques and you say, okay, this is looking similar. Not only this thing, you can relate this to multiple things. If you see the numbers are same, there it was CE, 2C, and C. So step 1, find the potential with zero node. Step 2, name the potentials. This is 2V, this is V, this is X. Step 3, assume currents flowing here, I1. I can take reverse also, doesn't matter. We get I1 plus I2 plus I3 is 0. So I1 would be V minus X by R. I2 would be 0 minus X by 2R. Because you're assuming current is going from higher to lower there. So this is 2V minus X by R. R goes off. You end up with V minus X by 2 plus 2V minus X. You get 3V is equal to 5X by 2. X is equal to 6V by 5. So yeah, so I1 will be how much? V minus this thing minus V by 5R minus N. But direction is wrong. It's not flowing towards X. It's actually going away from there. I2 will be 0 minus X, so 6V by 3V by 5R. This is also wrong. Current is flowing in the opposite. I3 would be 510 minus 4V by 5. Make sense? I hope you can see the similarities. Exactly same thing it was. Any doubts on this thing? Kirchhoff's junction law. Now you guys try this. Any doubts on this? Can I turn the page? Hanika, Neil, clear with this? Neil, Palaksh, Arjun, Yasha,
No, sir.
Udayan? Great. Unbalanced Richmond bridge. Find R equivalent and current in the branches. You know, numbers are bad. Try. Everyone should give it a try. So let's start this with 0. This is V, this is X, and this is Y. Hope you remember the process. Let this be I1, I2. Now see, I1, I2, I3 are just symbols. We really don't care exactly which way they're flowing. The signs will take care of them. I4, I5, I6. So when you take for X, current would be I1 plus I2 plus I3 is 0. V minus X by R. You can see this thing, exactly same thing it was. And I2 would be Y minus X by R. 0 minus X by 3R. R goes off, you end up with V minus X plus Y minus X by 3. This guy would be X plus X2, 2 plus 1 by 3, 3 to 6, 7X by 3 minus Y is equal to V. When you do the same thing for Y, what will do with the equation? Solve them, no? Don't be lazy than me, right? I'm telling you, know, questions like this will come, advancement. They do ask lengthy questions. People get lazy and they don't solve. This is a question where it is easy but lengthy to solve. Don't get confused between a tough question and a lengthy question. Lengthy questions you should not leave because everyone thinks, yeah, itna lengthy kaun kare. If your speed is fast enough, you can actually do this in 3 minutes. When you feel irritated and yeah, itna lengthy question, think about it. Everyone must be thinking the same. That means if you do it and other guy leaves it, that's what will make you better than others. So this guy is how much? X minus 5y by 2 is equal to v by 2. Take this guy and dump it in this. That would be 7 by 3. X ka value is v by 2 plus 5y by 2 minus y is equal to v. 7v by 6. 35y by 6 minus y is equal to v. 29y by 6. I'm getting a negative sign. I goofed up somewhere. I have taken I5, I2 in the opposite direction.
You have to take minus v by 2.
Where
Equation
minus ये ना yeah. But yeah, I'm getting negative voltage. That was something goofed up. So 13v by 6. Y का value आ गया. 13v by 29. You can try KVL. KVL में एक extra equation आएगा. You'll go more mad. Junction law में because you took 0 potential, you get 1 equation less. You can try Kirchhoff law. You'll get 3 equations to solve. And what about x का value? किसी को आया x? Substitute करना पड़ेगा यहाँ पे. तो how much you are getting? X is 18 by 29, it seems. There, you got x ka value and y ka value. What do you want to find? Resistance. So you got the current in the branches, you can find everything. We know R equivalent is voltage by current in the battery. I is the current through the battery. Now from here we can clearly see the current flowing here is I1 plus I4. Calculate I1, I4 and dump it, you'll get the answer. I will leave it to you. X and Y aa gaya, I1, I4, you'll get it. Anyone got it? Check it out. That much you can handle now. But clear with the steps. Let's see one more. You can't use any symmetry here, nothing. So this is complex. All clear with the steps. I think once you got the equations, then it's just a matter of brute force solving. There's nothing to think. Clear na, Ali? Anika? Got this? Utsa? Vartika? Clear na? Next one, going ahead. Going ahead, all clear, right? All our resistances are. Get me the equations. This is not a Wheatstone bridge. This is कैसा लग रहा है Wheatstone bridge? You're saying these two log हैं. Then what is this thing doing dancing here? This is not a Wheatstone bridge. Don't insult the poor thing. It'll feel bad. This is like a leopard. You're calling it a dog. The previous one is a pig. There was no symmetry, nothing. बाद में आएगा Godzilla. How do we approach this? There is a symmetry here. It starts with D. Deadly symmetry. Yeah, diagonal symmetry. Yeah. Think for a minute, then I'll show you. Then you can write the equations. Listen to the symmetry. So this is V. You're connecting the battery between these two guys. This is 0. Now, if I call this X, now look at the logic here. Whatever happens here, the same thing should happen in this junction here. Agreed? These 2 points are same. No, whatever happens, it will happen here. Whatever happens, it will happen here. Whatever happens, it will happen here. So you're getting how it is? So I'll show it in 2 ways. See. So if this was capital I comes out from here. Meaning you can just stretch the circuit a bit to keep it more symmetrical, but you got the idea there. So if this was I1, this should be I1. If this was I2, this should be I2. Are you making sense? So if you take this to be V and this to be 0, if you say this is X, now look at this thing. What is the potential difference V minus X now? The current is same. So this point should be V minus X. If you say this is Y, this point should be V minus Y. Are you getting this? Because current in this and current in this is same, the potential difference across the resistor must be same. And the distance ka value is same. So here what is the potential difference? V minus X. So this also should be V minus X. So V minus X minus 0. Are you getting the logic how diagonal symmetry works? There. So even though it looks complex, it is still a little complex, but at least you are saved. You have only two variables. So I can take this as one junction here, and I can take this as one junction here. So I will assume currents are like I1, I2, I3, and I'll assume currents here, I4, I5, I6, I7. There are 4 currents here. Apply the junction law. So I'm writing for X. We'll just write the equation and leave it. V minus X by R plus V minus Y minus X by R. Y minus X by R. It's not actually X and Y aa jayega easily. If you look at Y, V minus Y by R. Luckily, all are R's only in the denominator, so they'll just add up. X minus Y by R. V minus 2Y by R. V minus X minus Y by R. Simplify. You will get X and Y from here. Okay, someone did get a value, 5R by 4, it seems. I'm not sure though. So find X and Y, you'll get the answer. Someone is saying RAB, Swastika said 5R by 4. Might be. Looks decent also, must be right. So you guys can verify and check it out. Clear with this? Actually, it really is not that bad. Denominator, all are R's only, they'll cancel off. You'll get a pretty good equations. Numbers are not that bad. All got this? Let's see one more. Now, the same thing could have done in capacitors also. The logic would have worked. Turn in the page. Any doubts on this, please ask. This is B and this is A. Each segment is R. Find RAB. Let's get this. Others do keep your hands on. Just get me the equations. This won't simplify. Series parallel mein nahi aayega. You still have to use Ronal and Kirchhoff's junction law. 21R by 20. I don't know the answer for this. I don't know the answer for this. But I'm getting a feeling it's not good. Let's see. Why are you guys sorry? Don't be sorry for giving wrong answers, right? Do your work. If you're not doing work, you should be sorry about that. If you're getting wrong answer, that is fine. You're still trying. Series parallel नहीं है यहाँ पे कुछ भी. In what world this thing looking series parallel? Symmetry तो है. There is a which symmetry is there? Actual symmetry is there. So you can fold the circuit. That much you can do. So there is an actual symmetry. The line is passing through the point, so you can fold it. Up and down are parallel. This guy will become like this. This will remain R only because there is nothing to fold there. Remaining will be 2R. 2R नहीं.
R/2.
Parallel ना R/2. इतना तक simplify कर सकते हो. So there is an actual symmetry. All will be R/2 except these two guys. There is no one to fold on themselves, so they will remain same. If I just redraw this properly again, you will see the circuit 21R/20. Okay. If you got that, then it is good. So this thing is R/2, R/2, R/2. Niche 1R. And this thing will become 3R/2. One in the middle, one in this thing here. So it is one in the middle, one in the middle. So this is R/2. Check your resistances, R/2. R/2. This is 3R/2. This is R. This is not an extended Witron bridge. This is not an extended Witron bridge. Ratio manage नहीं हो रहा देखो. Ratio is not same. You can't remove anything here. The battery is between these two. So if you have used series parallel, then it is definitely wrong. This is a circuit. Nothing is in series and parallel here. But again, if you see, there is a diagonal symmetry. At least up and down, they look kind of same. So this much you can say, if this is X, this should be V minus X and this is 0. Makes sense? Whatever happens here, same thing will happen here. The upper branch current will look similar at least. If this is Y, this will be V minus Y. This much you can say. And then again, you have to do nodal analysis and you have to solve. You can take this junction here, I1, I2, I3. You can take this junction here, I4, I5, I6. I will leave it to you. You can solve that. You get X and Y from there and you're done. Then R equivalent would be P by I1 plus I5 in this case. Like I said, it is lengthy, meaning once you got the process, so there are two symmetries here. But still, you have to still use junction law. I hope you're getting why this is X and why this is V minus X. Because current in this and current in this is the same. Because see, left and right, they look same. So whatever current is here, the same current should be here. So if this potential difference is V minus X, this difference also is V minus X. That is the logic we are using. This is not a diagonal symmetry, but Hay symmetry. I don't know what to call this, but yeah. Clear with this? Any doubts on this circuits? Please ask. Let's see one more. Is it possible to find the resistance of a football circuit? 3-dimensional में. Symmetries तो है. Why है? Meaning see, football तक क्यों जाना है? Remember this 4x4 grid we talked about last time. यहाँ पे अटक जाओगे तो. फुटबॉल तक जाने की जरूरत नहीं है. This one you'll get stuck. We did 3 into 3. You'll be able to solve, but eventually problem क्या होगा ना, the equations and things will become so many, it will be just become lengthy. Clear with this? Next one. Perfect. All batteries are 1 volt. All resistors are 1 ohm. This point is A. This guy is B in the middle. Find VA minus VB. This is the kind of question you will expect in advance. The previous one is still, they might not ask because सोचने में इतना नहीं है. See, end of the day, even the advanced guy paper who makes the paper, he knows you have to solve it in 3 to 4 minutes. This is a very beautiful question. Matlab, you see this and first thing you get scared. If you like, what shit is this? 8 batteries, what is this? Terminals and all, and then you leave the question. That's what he wants. But if you actually calmly think and try to solve, you'll actually be able to do this in 2 to 3 minutes. So main examiner का mindset ऐसा होता है. 1, to scare you. 2nd, use your logic to think, not brute force. Brute force, even computer will do that. Try 2-3 minutes. Think about it. Give it a try. I'll just be back in a minute. Let's see, 4 by 9. Let's see. Same thing. Let's start with something as 0. Let's start A as 0. If this is 0, this is 1, this is 2, this is 3, this is 4. This is also 0. No, that is not 0. That is X because there's a resistor in the middle. If that is X, This is x plus 1. This is x plus 2. This is x plus 3. And this is x plus 4. So if I can find x plus 2, my job is done. I just need to find x ka value. I'll get VB minus VA. So VB minus VA is x plus 2. Now what to do? 22 by 9. People are getting 22 by 9.
So
How
just
did you
give 1 minute. I think I'm done.
Karo. See, now the idea here is we'll apply junction law, but in a little different way. The people who reported the answer, I hope you did the same. You know how to do this. So, see, remembering an answer is fine, but you should know how you're doing it also. If you just remember the answer, it is good for nothing. I'll just put 2 more branches and you'll get stuck. Look at this thing, look at this green line. Now, if I take this green line here, I will say this is I1, I2, I3, I4, I5, I6, I7, I8, I9. What can you tell about all these currents? The total current crossing this green line should be 0, isn't it? Because think about it. If you say I1 plus I2 plus I9 is not a 0, that means, right? Meaning all these things, right? The current is just going in one direction. Remember, the current starts from it, it has to come back again. If the current starts from a battery, shouldn't it come back to the battery? Or you can say current passing through all these nodes, the total sum should be 0, isn't it? Some nodes are receiving current, some nodes are giving current. Total should be 0. Is that making sense? Kush? Why it is not making sense? See, if you say all these are giving current, ये current जाएगा कहाँ पे, God? Where will it go? What does a battery do? Does it produce current? Whatever current it sent, it has to come back. If all these things send some current, all that current again should come back, right? Means whatever currents that are crossing this line, if some currents are crossing the line, some currents will cross back up the line again. The total should be 0. Making sense? The total thing is isolated. So the total current crossing the line should be 0. I hope everyone is making that thing making sense. So indirectly, I'm saying I1 plus I2 plus I3 I9 is 0. Is that making sense? The total current crossing the... Now, we are just treating this whole thing as one big node actually. The net current flowing through that must be 0, because see, if this thing is sending some current, it will come back again. If this is sending some current, it will come back again. It will come back, it will come back. So whatever is you're sending should come back again. Matlab net current kitna hona chahiye? 0. Every current that crosses the green line has to come back somehow to the battery again. So then you're done. So what is I1? Potential difference? X plus 4 minus 4. So that is x by 1. What is I2? X plus 3 minus 4. So that is x minus 1 by 1. X3 is x by 1. I4 is x by minus 1 by 1. X by 1. I6 is also, I think it is all coming like this only. I8 is x minus 1 by 1 and x by 1. How many x's are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I get it right? So I'll get 9x. 1, 2, 3, 4 minus 4 equal to 0. So x is equal to 4 by 9. VB minus VA is x plus 2. That is 4 by 9 plus 2, 18 plus 4, 22 by 9. Yeah, most of you are right. Easy. Any doubts on this logic? So you can do this for any number of branches, meaning if someone gives you a big circuit, you can just draw a line and say the total current coming from the top is 0. Because in a circuit, when you have a battery, whatever current you send, it has to come back. Matlab, the current will cross again back because charge is conserved. So we can be sure the total current is 0. Means you assume all are flowing in one direction, but some of them are actually negative. The science will take care of it. Clear? And now you can actually find the current in each battery also, this thing also. So it works out. Fine, you can find the current in each branch. There is no other way to do it. I never tried. So you can tell me if there is another way. Matlab, if you're saying like I will do some combination of batteries and stuff, I don't think so. Series parallel में कुछ नहीं लग रहा है. I don't think anything is in series parallel. कुछ भी नहीं है यहाँ पे. See na, not even a single node has same potential. Nothing we can do. Clear with this? So there, that is about the junction law. So next class when we catch up, we will do the Kirchhoff's loop law. Like I said, loop law is pretty useful when we have capacitor, resistor combinations and all. So next class we will do that. Then we will do RC circuits, resistance and capacitors combinations. That would be an important one. So yeah, and I think next Friday people are having major test, right? Base people. Next Saturday, next weekend, right? Or this weekend?
Next weekend.
Next weekend. Okay, so we will try to do as much as we can. We can finish it off next Friday. So then we won't have a class next Friday. Not this Friday, next Friday. So because of most of the people have a major test. So we will see them. Then that day will be only for doubt solving. Anyway, this Friday let's catch up. We will continue from here. We will try to do as much as possible. I think we'll finish off mostly, but instruments bach jayega. Ammeter, voltmeter and stuff. Okay, so with that we'll wrap up for the day. So any doubts in today's class? Anything, do stay back and ask. Especially today's problems, do try them again. Right? And do finish off your capacitor solving. Don't delay it more. Try to at least finish off capacitor solving by this weekend. So any doubts, anything, you can stay back and ask. Also free to